Let's look at OpenStax College Physics Chapter 4, Problem 41. Two muscles in the back of the leg pull upward on the Achilles tendon as shown in the figure. These muscles are called something or other. Find the magnitude and direction of the total force on the Achilles tendon. What type of movement could be caused by this force? Alright, so let's get organized here by writing down our knowns and unknowns and then drawing the diagram. Our knowns are given to us in the diagram itself. So we know that F1 is 200 newtons, and so is F2, and both of them make an angle theta of 20 degrees relative to the vertical. And what we're looking for is the net force that pulls on the Achilles tendon. So I'm going to just call that F net for a lack of a better name. Now for the diagram, I'm going to draw my two forces. It's a free body diagram where I don't actually draw the Achilles tendon, just the two forces. This one is F2, this one is F1. And I notice that they're not in the X or Y direction, so I'm going to choose my X and Y. I'll make my Y vertical, I'll make my X horizontal. So this is my X-axis, this is my Y-axis. And now I will project F1 and F2 onto the X and Y axes. So here is F1 and here is F2, my projections. And I will draw my X in red. So this will be my F1X. This would be my F2X. And then let's make Y yellow. So this is my F1Y and this is my F2Y. All right, so if I look at the values that we were given, both F1 and F2 are 200 newtons. And the angle that they make with a vertical is 20 degrees. What that means is that the magnitude of F1 and the magnitude of F2 is the same, and then since these two angles are the same, when I project them onto the x-axis, I get F1x to have the same magnitude as F2x, but the two of them have different directions. F1x is positive because it's in the positive x direction. F2x is negative because it's in the negative x direction. So what that means then is that these two x components cancel each other out. One goes to the right a certain magnitude and the other one to the left a certain magnitude. So their pull is going to cancel out. Now, the forces that we're left with are the ones in the vertical direction. So then the net force will be the sum of those two forces in the y direction. So that would be F1y plus F2y. And since this is angle theta and F1y and F2y are adjacent to angle theta, then adjacent goes with cosine. So we'll have F1 cosine 20 plus F2 cosine 20. And F1 and F2 are both 200 newtons, so we get 2 times 200 newtons times cosine 20. And when we plug in the numbers, we end up with 376 newtons as our net force acting on the Achilles tendon when it stretches it.